So I wanted to take this video to just kind of demonstrate some of those methods of evaluating limits and kind of in order we do it. So the first one here is I have the limit as r approaches 4, and that's a two-side limit, so it's from the left and the right, of r plus 4. To evaluate this, the first thing I try is let's just plug 4 in for r and see if we get a real number. So if I plug 4 in for r, I get 4 plus 4, which is 8. And that is a real number, and there we've evaluated the limit. This is why I said 95% of what we're doing with limits, this is how we want to evaluate them, because it is the easiest. Another note, as soon as I plug in the value for r, I do not need to rewrite the limit notation. On this next example here with simplify then substitute, you'll see that I am going to need to rewrite the limit notation because the limit notation is an operation like the square root sign. I have to keep writing it, as annoying as it is, until it's okay, until I've actually done the evaluation. So like if I have the square root of 16, I would write 4, the radical sign disappeared because I actually found the square root. So until I find the limit, I need to keep writing the limit notation. So here, the limit as p approaches 4 from both the left and right of p squared minus 16 over p minus 4. If I try to plug in 4, I get 4 squared, which is 16, minus 16 is 0, over 4 minus 4, which is 0. So I have 0 divided by 0. We're not allowed to divide by 0, so substitution doesn't work. So what I'm going to do next is see, because this is rational, can I simplify this to something I can plug 4 into P4 and get a real number? So I've not found the limit yet, so I do need to rewrite the limit as p approaches 4 from both sides. I can factor p squared minus 16 to be p minus 4 times p plus 4, and that's still over p minus 4. Well, now I can cancel out the p minus 4, and what I'm left with is I still have the limit because I still haven't actually evaluated it yet. I just have a p plus 4. And at this point, I can plug 4 in for p, and I get 4 plus 4. That is evaluated, so I found the limit, and I'm just simplifying it to give me 8. The difference between these two limits is this is a line with a slope of 1 and a y-intercept of 4 that is continuous for all of the r values. This graph would look like a line with a slope of 1, a y-intercept of 4, but would have a hole at 4. But even though there's a hole at 4, I could still find the limit. And this kind of illustrates that for us. So here, I can see it's continuous, slope of 1, y-intercept of 4, continuous slope of 1, y-intercept of 4. I can even see on the table, as I get closer to 4 from both sides, it looks like it's approaching a value of 8. So from a graph or table, it's the same idea. I can even approach this with piecewise functions. The difficulty with piecewise functions is I have to pay attention to which piece I am using. So here, I have the piecewise function of x plus 2 when x is greater than or equal to 5, and 3x when x is less than 5. The limit as x approaches 5 from the left of f of x, well, I would do the limit as x approaches 5 from the left. If x is approaching 5 from the left, that means my x's are numbers like 4 and 4.5. They're less than 5. So which piece would use x's that are smaller than 5? Well, I would use the first piece of x plus 2. And then I would see, can I do substitution? Can I just plug 5 in for x and get a real number? Well, yes, because I get 5 plus 2, which is 7. And there's my limit from the left side. If I then look at the limit as x approaches 5 from the right of f of x, well, that means I'm doing the limit as x approaches 5 from the right. But now, if x is approaching 5 from the right, those x's are bigger than 5. Whoops, I made a mistake here. Let me go back and fix my mistake. Drawback of doing this on a video instead of in front of students. I used the wrong piece here when I was going from the left. 3x is for when I'm smaller. And x plus 2, x is approaching 5 from the right. X plus 2 is when x is bigger than 5. So then this would be 7, and I can do substitution here. This would be 15. Well, then for the two-sided limit, this only exists if the left and right-hand limits are the same. They are different, so the limit does not exist.